Hello. Today I want to show you two examples of reducing matrices. We want to reduce the matrix to row-reduced echelon form. The definition of row-reduced echelon form, I hope you have learned already, and now we shall practice this reduction. I have prepared for you a nice matrix, 4 by 3. We always reduce first column, then second, then third, moving left to right. And what to do here? In the first column we don't have a pivot, but if you look more carefully, we can reduce by 2 in the first row, and then a pivot will appear. Also, by inspection we discovered that the fourth row can be reduced by 2, so let's do this right away. So we reduce by 2, multiply the first row by 1/2, and same with the fourth. The new configuration I can indicate with arrow. So we have now 1, 0, -2, 3, -1, 2, 0, 5, 7, no change here, and then reducing by 2 we have -4, 0, 5. Okay, so we have a pivot now in top left corner, and we use this pivot to make zeros below. So we shall multiply the first row by -3, add to the second, and then we shall multiply the first row by 4, add to the fourth. So let's do these operations. The first row does not change. Then the second becomes 0 first. -1 is not changing because we're adding 0. -3 times -2 is 6, and 2, 8. We're not changing the third, it's good enough. And here we have 0, another 0, and then we multiply by 4, that's -8, -3. So this is the result. You see now the first column is completely reduced. This is really very good. And we move to the second. In the second column we don't have exactly a pivot, but this -1 works very well. The second row we can multiply by -1 later, but now I can use this -1. Also, notice in the fourth row there is only one non-zero element, and I can make 1 here if I stay with this 3. So I can do 2 operations, independent operations at the same time. Multiply the second by 5, add to the third, make 0 below. All the other elements in this column will be zeros. And also divide the fourth one by -3. 2 quite independent operations. Okay, so what will be the next configuration? 1, 0, -2, no change. 0, -1, 8. 0, 0 now. We multiply by 5, so there'll be 47 here. And the last row is 0, 0, 1. Okay, the second column is practically reduced. I shall multiply it by -1 to make real pivot here. And then the third I shall divide by 47. Just make 1 here, there'll be good pivot. We don't need this 47. And here is the next configuration. 1, 0, negative 2, 0, 1, negative 8, 0, 0, 1, and again 0, 0, 1. We're very close to finishing this, and now I shall use the pivot in the third row. This one. Make zeros above and below. And why not the fourth one? Because in the row-reduced echelon form, then we shall to get the row-reduced echelon form, then we have to move the fourth to the third. And now, if we just make zeros in the last row, we shall get exactly the row-reduced echelon form. So I'm going to work with this pivot. And making zeros above and below is very easy. Multiply the third by 2, add to the first, multiply by 8, add to the second, and then just subtract the fourth minus third. Subtract the third from the fourth. So let's see what we have now. 1, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0 only. This is the row-reduced echelon form. Every row starts with the pivot 1 or 0. Above and below pivots we have only zeros. Every other pivot going down is to the right of the previous. And if we have a row of zeros, it goes last. And that's it. What was important here, it was not crucial, but very important and good to reduce. We reduced the first row to get a pivot. And also we reduced the fourth one to make numbers better. Another example. Look at this matrix. Now it's a matrix 3 by 4. First row is 0, 3, 0, 3. Then 2, 1, 6, 6. Then 3, 2, 10, 5. Okay, in the first column we don't have a pivot. At the same time, we notice that the first row we can reduce by 3. That's something good to do right away. 1/3 the first. Now I want to do something independent to organize a pivot. We can organize a pivot down left corner if I subtract the second from the third. So third minus second for pivot. I need a pivot to start my reduction. So these are two independent operations. Here the first divide by 3, 0, 1, 0, 1. And no change in the second. And now we subtract the second from the third. So here we have 1, 1, 4, negative 1. We have a pivot in the first column. It's in the last row. And we don't need to have this 0 on the top. So right away, let's swap the first and the third. Just to follow the standard and work with pivot from the top left. So there will be 1, 1, 4, negative 1. I'll have to squeeze a little bit here. Second is the same. And first becomes third. Here we have an obvious operation. We multiply the first by negative 2, add to the second to reduce the first column. The first is not changing. 1, 1, 4, negative 1. Okay, and then we have 0, negative 2, negative 1 in the second position, negative 8, negative 2 here, and 8. No, so, yeah, plus 8. And 0, 1, 0, 1, no change here. Okay, first column is reduced. Now I'm moving to the second column. And I can use the third row. I can use for pivot the second element, the third row, because I will have to work with smaller numbers. Otherwise, with this 8, 8 here, it's more difficult. Then we can change rows if necessary. Well, so let's do this now. Second plus third. Make 0, and then first minus third. What is happening? Subtracting the third from the first, there will be 1, 0, no change here, and negative 2. Adding third to second, 0, 0, negative 8, no change, 9. 0, 1, 0, 1, here no change. Look, the second column is very well reduced. And now I will put the third in the second place, because this will be more natural to have a pivot in the second position, in the second column. So I shall swap second and third. With this arrow that points both ways, I'm indicating this operation, swapping, and here is the result. 1, 0, 4, negative 2, here no change, 0, 1, 0, 1, 0, 0, negative 8, 9. The second column is reduced and just in perfect standard. Now I have to look at the third column, see what to do. In the third column I don't have a pivot. And the only way to organize a pivot is to divide it by negative 8. Because I cannot use the entry 4 in the first row. I cannot work with this because the pivot will move. The pivot in the first row will destroy zeros below. So this is the only way I can make a pivot in the third column. We'll come to fractions. So the next position will be 1, 0, 4, negative 2, 0, 1, 0, 1, 0, 0, 1, and negative 9 eighths. Okay. Now I have this pivot. Let's show it clearly. I need to make zeros above. I need to make 0 in the first row. This 4 should be removed. So I'm going negative 4 third plus first. Okay, this becomes 1, 0, 0. What comes in the place of the last element? I'm multiplying by negative 4, 9 eighths. This will become 9 halves in this position. And I have to add it to the first. It will be negative 2, negative 9 halves. This will be negative 13 halves. This is what happens here. negative 13 halves in this position. I don't make any other operations, so just rewriting the others. 0, 1, 0, 1, 0, 0, 1, negative 9 eighths. So this matrix is in row reduced echelon form. The first column is reduced, second is reduced, third is reduced. It satisfies the definition of row reduced echelon form. The last column we cannot reduce. Now, if for some reason you want to use this entry 1, the last element, the second column, to make zeros above and below, the pivot in the second column, this element 1 here, will destroy the zeros above and below. So we should not do this. The element, this entry 1 here, is not a pivot. The real pivot is this one. Let me show you all these 3 pivots. These are our pivots. And we have to stop here, and this is what we get. This is the row reduced echelon form of the matrix. Okay, so this was my second example, and I'm stopping now with this lecture. I want to tell you that there are detailed notes with many more examples and the homework. So please follow the lectures in Moodle. Goodbye.